Good morning, students. Today we can discuss about microstates and macrostates. Consider an example consisting of large number of independent systems or a gas consisting a large number of molecules in a space. The state of an individual system or a molecule may be represented in a space by a point known as space point. Each arrangement of a specified system or a molecule with their representative points in a particular cells is called a microstate. In other words, a microstate of an ensample may be defined by a specification of an individual position of space points for each system or molecule of an ensample. Thus, in a microstate, we have to state to which each system or molecule belongs temporarily. Next, macrostates. Therefore, first considered an macroscopic behavior, it is an immaterial which particular system or a molecules are occupying the specified cells. Therefore, a macrostate of an ensample may be defined by the specification of a space point in each cell, that is, by specifying the number of particles only and overlooking the identities of a system or a molecules. It will be sufficient to say that there are n1 space points in first cell, then n2 space points in a second cell, and so on. A change of a space points between two cells in space shifts this position of unit cell because the microstate change. But from the point of view of microscopic properties, this exchange makes no difference because it is an immaterial which of the molecules are in a particular cell specified by numbers. For example, 1, 2, 3, etc. Thus, there may be many different microstates which may correspond to the same macroscope. For example, let us consider as cells, cell 1, cell 2, cell 3 up to cell I in a particular space. Suppose there are 4 base points A, B, C, D in cell 1, 3 phase points next E, F, G in cell 2, 1 phase point H in cell 3, and 2 phase points JK in cell I are shown in adjacent blocks. The microstate of figure is specified by giving the space points n1 equal to 4, n2 equal to 3, ni equal to 2 for different cells. This represents a particular macrostate by specifying the positions of the space points a, b, c, d in cell 1, e, f, g in cell 2, and so on. Now, if the two phase points a and e from different cells are interchanged, then the microstate is changed because the position of two phase points are changed, while the microstate remains the same as the number of phase points in cell remains the same. Similarly, with the same microstate, we can consider different microstates. Thus, different microstates may correspond to the same macrostate. The microstates which are allowed under a given restriction are accessible microstates. One of the most fundamental postulates of statistical mechanics is that all accessible microstates corresponding to the possible macrostates are equally probable.